In this lesson, you will learn to understand the different aspects of line segments, rays, and distance. So starting with line segments, we see here an example of a line segment. Okay, it starts at point A and it goes to point C. Now as far as giving a definition of this, it is simply a measurable section of a line, which makes sense, right? Because a line segment would be a segment or a portion or a section of the line. So remember, a line keeps going forever and ever and ever, whereas a segment, it does have a beginning and an ending point. So take note of that difference between line segment and line. It is a small nuance, but it does make a difference. Okay, now as far as naming this, we see that it has point A and point C, so we'd call this segment AC. Now more specifically, point A and point C are what's called the endpoints. It's where it begins and where it ends. So the segment AC would consist of the points A and C, and then every point in between points A and C. And as far as naming them, we use those endpoints, A and C, and we put a segment symbol above it. So we see here, we can write this as AC or CA. Either way, it's the same thing, as long as we have the correct endpoints. Okay, and that's different than a line AC, because a line would have the little arrows above it. So if it's a line AC, it would look like this, whereas a segment just has the segment symbol above it. Now with segments, if we want to know the length between 2 points, so for example, given points D and G, what is the length of point or segment DG? Well, all we do as far as describing this, instead of writing out every time what is the length of DG, we could write simply DG. So DG, just the letters next to each other, would mean what the length of DG. Okay, with a ray is another term to know, and it's similar to a line and a line segment, but we see here a ray has only one endpoint, and it keeps going forever in one direction. Okay, so a ray has a specific starting point and goes forever one way. So we would say this as ray AC, where A, the first letter, is going to be your endpoint. And then the second letter is the other line that it goes through. And as far as labeling this, we can use here the notation A, C, and then the ray symbol above it. Okay, so that would be a shorthand way of writing the same thing. And as we said, the endpoint is going to be the point that is named first. So the A would come first because that is where it starts. That would be different than writing ray CA, because CA would imply that C is where it begins and A is the other point that it goes through. Okay, so if it was going to be CA, it would be turned around the other way. Maybe another way of thinking of a ray, if you're struggling with this definition, a ray is basically like half of a line. A line keeps going forever in both directions, whereas a ray just goes in one direction. So whatever way you want to think of this, we have here a ray is another term you need to know. Now opposite rays is another term to know. Opposite rays would be two rays that form a line. So for example, here we have one ray going to the left, and then here we have another ray going to the right. Those two rays would be opposite rays because they're going in opposite directions and they form a line. Another term to know is what we call postulates. Postulates is kind of a weird sounding word. Another name we have for this is what we call axioms. That's also another weird sounding word, so the question is, well, what do both of these mean? Well, a postulate or an axiom is simply a statement that is accepted without proof. So something that is very self-evident that there's no need to actually try to prove that statement. So for example, we can say that this would be a postulate where it's possible to draw a straight line from any point to another point. If you have 2 points, it's obvious that you can draw a line, a straight line between those 2 points. There's no need to prove that because it's obvious. And then another example would be that all right angles are equal to each other. Right angle means it makes a 90-degree angle. So obviously, every right angle is going to be the same size, right? They're all going to be 90 degrees. That's based off definition. So there's no need to prove that because it is self-evident. Okay, so that's the idea behind postulates or axioms. And those are pretty simple examples, but there are some that may not be quite as simple, but yet they are obvious in the sense that there's no need to prove them, because you can just use simple logic to see very easily that these would be true. So for example, here we have what's called a segment addition postulate, where it says that if B is between A and C, then AB plus BC equals AC. Now that's a lot of words and math that might sound a little confusing, so let's put some actual numbers to this. So remember this notation, AB and BC and AC, we just discussed this, but if you have 2 letters next to each other, there's no symbol above it, what this means is the length. So this is length of AB plus the length of BC equals the length of AC. So let's say AB was 4 inches. So from this point to this point is 4 inches. And then we knew BC to be 10 inches. So from here to here is 10 inches. And then the question is, what is the length of AC? So what's the length from A to C? Well, if we know this to be 4 inches and this to be 10 inches, then the length all the way across from A to C would be 4 plus 10, which would be 14. And that is the segment addition postulate, where the math notation up here might be kind of confusing, but just using actual numbers with this example, 4 inches and 10 inches, it is self-evident that we just simply add those together to get the length of the entire segment. And that's the idea behind a postulate. And this one specifically is called the segment addition postulate. There's another term to know, another definition, and that is the word congruent. You'll see this word all throughout the course, so it's important to get a grasp of what this means. And the word congruent, all it means is 2 objects with the same size and same shape. Now it can be any shape. It could be here segments, but it could be squares, could be circles, could be anything. As long as they're the same size and the same shape, we would say that they are congruent. So here we have segments that are congruent. And the symbol for congruent, instead of writing out the entire word every time, we use this symbol right here. So it's like an equal sign with a little squiggly line above it. And this is the symbol for congruent. So here we have 2 congruent segments where we have the same shape because they're both segments, and they're the same size. They're both 4 inches, so therefore they are congruent. So we can say that we have equal lengths. And we would write this, in this case, as AB is congruent to CB, or CD. And need the segment symbol above it as well. So the segments are congruent. Segment AB is congruent to segment CD. Now there is a slight technicality that I need to point out, and that is the fact that segments are congruent, whereas lengths are equal. So for example, we see segment AB and segment CD. Okay, those shapes are congruent. So shapes are congruent. AB is congruent to CD, whereas the segments, the lengths of the segments are equal. So AB would equal CD. So take note of that nuance. Remember, the symbol above means that we have a segment AB. So because we have segment AB as noted by that symbol above, therefore they are congruent. And then if there's no symbol above it, like AB and CD down here, that means that they are the lengths of AB. And the lengths are equal. Okay, the lengths are a number. Numbers are equal. However, shapes, like segments, are not equal. They are congruent, but shapes are not equal, only the length, because the length is a number. There are a couple more definitions that you need to know as we conclude this lesson. The next definition is the word midpoint. The midpoint of a segment is the point that divides the segment into two congruent segments. So here we see an example where we have segment AC, and notice point B is in the middle. Okay, it's in the middle because it is creating two congruent sides, two congruent lengths. AB is 4 inches, BC is also 4 inches, so B has to be in the middle. So B, we would say, is the midpoint of that segment, of segment AC. And that is different from the next term. The next term is the term bisector. So a bisector of a segment is a line, segment, ray, or plane, or anything that intersects a segment at the midpoint. So a bisector goes through the midpoint, whereas the midpoint is simply the point in the middle. So here's our same picture. B, we said, is the midpoint. Now a bisector would go through that point. So the line that we just drew would be the bisector of segment AC. And that is everything for this lesson, and we will see you next time.